Hi everybody. So I got really sick today. I'm not feeling tip-top, but I've had my pain medication and I got my special beef noodle soup, which is hopefully now working its beef magic on me. So I'm hoping to be better by Thursday, but I'm recording this video now to help you so that you'll have code that you need by Thursday. In class today we made bubble sort, which I'm going to run through again in just a second. And then you'll also need an implementation of selection sort, which I'll do as well. I think it's a great idea to follow along this video with me, but the way that you'll know you really have it is when you're totally done, delete everything that you just did together with me, and then recreate it yourself from scratch. It's going to take, this video is probably going to be about 15 minutes because I'm going to be talking through it. You should be able to do it yourself, both methods, in less than 10, because you can do it a lot faster if you're not explaining it at the same time. So that's your goal. Like for people who really want to get it, that's your test to see if you really got it. All right, so intention-driven programming. So I've got my main method. Remember, we were going to write getRandomArray, so I'll hit Alt-Enter to create the method. I'm going to rename this to size, which I think is a better name for the what the parameter describes. I'll create my return array named R. New int. And it's going to be of size. Then I'm going to iterate over it. Remember, you can use the iter, I think it's called a hot template maybe. And then array element I is going to be casting to int math.random times, what did I call it? Max val. Okay, so I'm generating random numbers from 0 to max val. I'm filling the array with them, and now I'm going to return the array. Okay, so you might not have known this. This is called code folding, so you can kind of collapse that, and now you just see the method signature, and you don't need to see the method body. Let's do bubble sort. So remember, the idea, the pseudocode for bubble sort is over and over and over again, we're going to traverse the array, swapping adjacent elements that are out of order. And we're going to count the number of swaps, and we're going to keep traversing the array as long as it's not sorted. And we're going to know that it's not sorted, we're going to know that it is sorted when the number of swaps equals 0. So that's the kind of pseudocode. So since I know I'll need to count the number of swaps, I'll make a numSwaps variable. I'll make a do while loop here. So while numSwaps is greater than 0, I know that it's still out of order because I'm still making swaps. And then I'll say numSwaps. Notice I'm using the tab, and tab equals. And then let's call it traverse and swap. And I'm going to give it the test array as input. Okay, so now let's implement traverse and swap. So here's that. So I'm gonna iterate the input array here. I'm going to need to count how many swaps. So again, I'll need numSwaps. And here I'm going to test to see if the elements are out of order. So test array, if I is greater than element I plus 1. So if the smaller location has a larger value than the location right after it, I know they're out of order. And if they're out of order, I want to swap them. So I'm going to create a method called swap, where I give it the 2 locations I want to swap, and the name of the array that I'm trying to swap them in. And then because we're counting the swaps, I'll increment numSwaps, which I will then return at the end. Notice how fast that goes when you use the tabs. Okay, so let's implement swap. That's down here. I'm going to name the locations I and J, or if you wanted to be even more explicit, you could call it location 1 and location 2. I'm going to call it R. And this is the pattern for swapping that's hopefully familiar to you now. Okay, so lock1 equals array location 2, and then array location 2 is going to equal what was in the temp. All right, so I've got this swapping method. The swapping method is being used in my traverse and swap method, where I'm counting the swaps and returning them. Oops. And now that's being used inside this do while loop, where I'm continually swapping as long as I made swaps, and then at the end I'll return my test array. I don't like the name test here, so I'm going to hit Shift F6, I think it is, yeah. And I'm going to rename it R. I'm going to rename this one R also, Shift F6. And when you do Shift F6, that renames this variable everywhere that it appears. Okay, so that was bubble sort. Cool, it only took less than 5 minutes. And I was talking, so that's pretty good. Okay, let's delete bubble sort and let's implement selection sort. And I'm going to use the test array. So again, put the cursor on the unimplemented method, hit Alt-Enter, and create. Except this time I'm going to call the array R right off the bat. So the idea of selection sort was loop starting location from 0 to the end of the array, then find location of smallest number starting at the starting location, and then swap that smallest number into the starting location. So in other words, we find the smallest number in the whole array, and we swap that into index 0, because that's the starting location. Then we go back to the top of the loop. Starting location is 1, and so we find the smallest number starting at location 1, and then we swap that number back into location 1. So now location 0 and location 1 have the first two smallest elements. And you continue that process of finding the next smallest in the kind of tail end of the array and then swapping it into the next kind of open spot at the beginning. So that's our pseudocode. So let's do it. I'm gonna iterate the array, only instead of calling this I, I'm gonna call it starting location. That can still be array. So I'm starting at location 0 and I'm looping all the way to the end. So now that I'm doing that, I'm going to get the location of the smallest number. So smallest num location equals get smallest num location starting at starting location. And then I've got to give it the array that I'm trying to find that location in. So here, let me make this smaller. Okay. Maybe if I thought for another minute, maybe we could find a method name that was better than this, that wasn't quite so long. Okay, so let's create that. Actually, let's assume this is working for the moment. So I'm going to find the location of the smallest number starting at this place. Then I want to swap. Oh, how convenient, because I've already written the swap method, so I can just reuse the one I already have. And I'm going to swap the thing at the smallest number location with the starting location. And I'm going to give it the array that I'm swapping in. Cool, and that's it. And we don't need to write swap because we've already done that part. So at the end, let's just return array. So the only thing I really need to do now is write this code that will find the location of the smallest number starting at the starting location. So let's do that. We've got this pattern where we're going to find the smallest, right? So let's implement that pattern. So smallest so far is going to equal the array. I'm going to initialize it with whatever the array at the starting location is. I'm going to have the iteration pattern, but I'm going to start at starting location +1. I'm starting at +1 because I've already looked at the starting location, because that's what I'm initializing my smallest so far to be. So I'm going to start 1 after that. I'm going to loop to the end of the array. And then I'm going to ask if the element at location I that I'm looking at right now is smaller than my smallest so far. Again, look how fast when I use the tabs. Then I want to save a new smallest so far. That's the current element I'm looking at. Cool, and so I know that by the time I'm done with this loop, every single time I find a smaller element, it ends up being smallest so far. So by the end here, the smallest so far is actually the smallest in the entire array. But the problem is, I don't really want to return the smallest number I find in the array. I really want to return the location where I saw that number, because that's the location that I want to swap with. So if we want to find a location, we'll need another variable. So location of smallest. So I'm going to initialize that to the starting location, because I initialized my smallest so far as the value at that starting location. And now whenever I find a new smallest value, not only am I going to update my smallest value that I've seen, but I'm also going to update where I saw it. So because the value at I is the new smallest, that means I is the location of the new smallest. So I'll save that into location of smallest. And so now I can return location of smallest. This is not the only way to do it. There's actually a sort of slightly shorter way to do this. And if you thought of it, way to go. Otherwise, this is fine. Okay, so cool. So I think that's all done. In class, we'd sort of done a rough test of bubble sort. Let's do our rough test of selection sort now. I'm just going to run it. And it certainly looks like these are in sorted order. I mean, that's not a slam dunk test, but that's at least a sense check to show us that we're not crazy and that we have at least beginning evidence that this is working. Okay, cool. So, again, that was about 10 minutes with talking. So if you want to be sure you've got it, like I said, delete that whole thing and run through it again yourself. So think out the pseudocode and then practice just typing the patterns in, because these patterns, don't go away in this unit. They keep happening for the entire rest of your programming life. So if you can get super good at them now, you will be good forever.